Okay, so let's come to the questions 21 through 30. Now, what I just noticed is that these questions are very similar to questions that appear in the SLMC 2023-13, which means I'm not going to go through the complete solution. However, I'm thinking of giving you obvious hints. So if you're watching this video for the first time, well, first go and do the paper and then come back again. And then if you find it difficult, use my hints. And if you still find it difficult with the hints as well, you can go and watch the previous video where I discussed question number 21 to 30 in the SLMC 13, and you will find the solutions, completely worked out solutions there. So this is like a pathway in the ladder of solutions. I think that would be a better way to use my screen time here. So here, integers a, b, c, and d satisfy the inequality 20ab equals 23cd. You have to go through the solution really fast. So think of one pair that makes this work. Think of one pair that makes this work. And the answer is in the other video. So please, I think it's going to be quite obvious when I say it. Okay. 4 integer numbers have the sum s and the product 16. And you can see the answers are negative. Some of these answers are negative, which means negative is a possibility. So what would give you the largest negative value? Well, you can have negative 16 and 3 other numbers that gives you the sum plus 60. And think of what numbers would go in all these 3 positions. 23. How many solutions does the equation x minus 1 absolute value minus 1 minus a is equal to b, or x minus a is equal to minus b. Using that consecutively, you will be able to solve this. So that's an actual algebraic manipulation, but also you can think of this as a graph. Absolute value of x minus 1 is this graph, and you subtract 1, you will have this graph, and then you take the absolute value. Instead of going down, it will go up. Okay. And then you subtract 1 again to make it 0. You will bring that down like that. So see how many times it can intersect the x equals 0 line, y equals 0. How many distinct factors does 2023 squared have? Well, find the factors of 2023. That would be 7 times 17 squared. So 2023 squared is going to be 7 squared times 70 to the power 4. So if you want a distinct factor, what you can do is you can think of how you can break this up. How you can break this up. And then how you can use this to get distinct pairs of numbers. And see how many distinct pairs you have in that sense. The full solution is in the other video. 25. The sequence 1, 3, 7, 9, 11, 13, 17 is formed by removing multiples of 2 or 5 from positive integers. So let's, I'll go to the next one, okay, where I have both of these questions. So this, let's see like this, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you can see these actually get cancelled out. Sorry, multiples of 2 or 5. Okay, so this is how it get cancelled out. Okay, 5, and then this, and then 6, 8, 10, and then 12, 14, 15. So you can see only you get 2 out of 5 numbers in the sequence. And because this is a regular pattern, it continues. So for each 5, you get only 2 numbers. So with that, think of how many numbers less than 1000 are in the sequence. And also, you can immediately guess how to get to the 2023rd number. For example, if you want to find the 10th number, you would multiply 10 by 5 over 2. That would be 50, but 50 is not in the sequence, so it should be either 49 or something like that. Okay. Let's move on. 27. 10 distinct numbers from 1 to 15, inclusive of 1 through 15, were selected. Which of the following cannot be their average? And the actual average is 8. So that number is not too far from 8. Okay. I mean, the number that is further, when you go further and further, you can't have it as an average. So it should be the number that is furthest from 8. So think about that number and tell us that, make sure that it is not the average. Okay, let's move on to the next one. So again, the complete solution is in the next, the other video. A, B, C, D are positive integers. A plus C, B plus C equals D, and A, B, C divides D. Okay, so that is A, B, C divides D. That would be A, B, C divides D. So that would be M times D. And then A plus B plus C is equal to D. What you can do is divide all this by A, B, C. So divide this side by A, B, C. Okay, so I think something like that. And divide all by A, B, C. Okay, and then you get M here. And then what do you get here? And what value would maximize M? And if you answer that question, you should be able to get the answer for that. Question number 29. What is the positive integer n that satisfies 10 to the power n plus 1? 1 over 10 to the power n plus 1 is less than this number. So here, I think the first thing that you can do is multiply by the conjugate of this number. And then on the top, you will have 2023 minus 2022. So you have 1 over root 2023 plus root 2024, but 2022. And each of these numbers are close to 45 because 2025's square root is equal to 45. With that in mind, you should be able to solve this problem. Again, the complete solution is in the other video. And finally, Sn denotes the digit sum of n. So it's like S of 456 is 456 is 4 plus 5 plus 6. So what I want you to do is, think of what is S of 10, S of 100. think of what is S1 plus up to S9 and see how it is different from S10 plus to S19 and see how it is different from S20 plus S29. So you will see that this is going to be 10 plus S1 to S9. And this is going to be 20 plus S1 up to S9. And similarly, you can go all the way up to S99 and then S100 up to S199 is going to be some constant, something plus S1 to S99. So you can add it like blocks and keep understanding how the pattern forms. Okay, should be not that difficult. It just is a little more calculation. However, the idea is go through questions 1 through 20 really quickly so that you have enough time to do these real big calculations that at the end. So the complete solution is again in the other video. So for this part, I only gave you copious hints so that how you can do the problems by yourselves. The answer should be 28,162, but it will take you a little time to answer that one. So I hope you enjoyed the discussion on questions 1 through 30 of SLMC number 11, 2023. I will see you with a discussion on a separate SLMC paper on another time. Thank you so much for joining with me. I will see you.